All right, 2.1 notes for geometry. Today, at the end of this video, you will learn to use inductive reasoning to identify patterns and make conjectures, and find counterexamples to disprove conjectures. So the first thing we're going to do is identify a pattern using inductive reasoning. Inductive reasoning is when you use patterns and observations to come up with a conclusion. That's inductive reasoning. And put a star by it because it's really important. There's always one type of question like this on the state test. So inductive reasoning, you're using patterns and observations. So for number 1, it says identify the next item in the pattern, 7, 14, 21, 28. Well, if you notice, each one is going up by 7 each time. These are multiples of 7. So if you add 7, the next thing would be 35. So that's the answer for number 1. Number 2, if you look at this triangle, it's turning to the left each time, about I don't know, 90 degrees. So let's see, if you turn this one left, it would look like this one. So if you take this one and turn it to the left, it should look like this. So I want you to try to do number 3 on your own. Number 2, you're going to make a conjecture. So we're using inductive reasoning to make a conjecture. So again, inductive reasoning is when we use patterns and observation. So conjecture is a statement you believe to be true, like a hypothesis, if you will. So for 4, 5, and 6, I want you to complete the conjecture. So here is a statement that I believe to be true, and you're going to fill in the blank. So the sum of 2 positive numbers is blank. They didn't give you any numbers, so that means you get to choose and try different numbers. The only exception is that there has to be 2 of them, and then they need to be positive. So positive means non-negatives. Some good numbers to try are 0, 1. You should try fractions. If possible, try negative numbers, and try big numbers. These are all good numbers to try. So the sum of 2 positive numbers. So we can't do negative. So let's see, random 2 positive numbers, 0 and 3. If you add them up, because sum means add, the answer would be 3. Let's see, something else. I would try at least 3 different tries. So 0 plus 3, let's see what else. 1 plus my lucky number 13, and then let's see, fractions. I said fractions. So 1/2 plus 1/3. Okay, 1 plus 13 is 14. 1/2 plus 1/3 is 5/6. I'll help you if you don't know how to do that. And then we have 0 plus 3 is 3. So looking just at the answers, what do we notice is the same about all of my answers? Let's see. Some of you guys might think, well, maybe my answers are always going to be even. Well, 3 isn't even, so even and odd isn't an option. Even or odd is not an answer. What about the sum of 2 positive numbers is always going to be 0? None of my answers are 0. What is similar between all of these? The only thing that's similar is that they're all positive. So the answer to this conjecture, to this statement, is the sum of 2 positive numbers is positive. The answer is always going to be positive. Let's see. Try number 5. Number 6 I'll do with you. The number of lines formed by 4 points, no 3 of which are collinear. Collinear means all in the same line. So I'm going to find 4 points, and 3 of them cannot be on the same line. So 1 and 2, there's 1 point and 2 points. Let's see. And then the third one can't be on this line. So here's the third point over here, and here's another point over here. So how many lines are formed? Let's see. 1, 2, 3, 4, 5. I have 6. So I'm going to say 6. Try it and see if you can come up with any more lines. Last example. Number 4. Find a counterexample. Counterexample is to prove something wrong. A counterexample can be an example, it could be a number, it could be a picture, it could be anything. So the last thing you're going to do is show that the conjecture, this statement that I believe to be true, is false by showing a counterexample. So for example, 2 complementary angles are not congruent. Let's say somebody comes into the classroom and tells you that this is true, and you don't think they're true. 2 complementary angles are not congruent. Complementary means that they add up to be 90 degrees. So if you think about a right angle, and we're talking about two angles, I'm telling you that they can never, ever, ever be congruent. What happens if this angle is 45 and this one is 45? If they add up, are they going to be 90 degrees? Yes. And are they congruent? Yes. So here, this is my counterexample. You can use a picture. Okay. And then 8. For every integer, this is just a whole number. For any whole number, n cubed is always going to be positive. Always going to be positive. Well, what happens if I have a negative number? Because I want to prove this wrong. So to prove it wrong, you're going to do the opposite. So instead of a positive number, you're going to try a negative number. So pick any negative number you want. I'm going to try -1. If I cube it, that means I'm multiplying it by itself 3 times. So -1 times -1, that's +1, and +1 times -1 is -1. Is this always positive? No. So your counterexample could be -1. It could also be -1 million if you wanted to. It doesn't really matter. You're going to try number 9. The fun fact of the video, only 2% of people can lick their elbows. Have fun.